Hi everyone, welcome back to our videos on C programming. So for today's topic, we are going to be discussing on variables. So what is a variable? How to declare a variable? What are the different ways in which we can make use of the variables? What is the role that a variable is playing in our programs? So these are some of the questions that we are going to be addressing in this particular video. So let us move on. So first thing is, what exactly is a variable? So a variable is nothing but a name that is given to a memory location where we want to store some values and keep. Let us say, for example, I am designing a game. So the game is consisting of a lot of violence and other things is there. So a lot of shootings, killings, like that. So what I want to do is I want to keep an age restriction. So I am saying only those who are above 15 years can play this game. Same way, I want to maintain a scoreboard. So I want to say whichever user is getting more number of points. So I want that details also to be displayed. So what I'm going to do is, as soon as a player downloads my game, the first thing I'm going to ask them is like, okay, what is your name? Or at least what is your display name going to be like? So then I'm going to ask, okay, what is your age? So if the age is above 15 years, I'm going to allow him to play the game. Otherwise, I'm not going to do that. Okay, so for this, the data what I am getting from the user, that is nothing but his name and his age. I need to store that data somewhere in my in things and keep so that I can make use of it in my program. So what I'm going to do first, I have to get the information. Then after getting the information only, I have to perform a validation. Okay, whether the age is appropriate or not. So until I do the validation, where is the data going to be there? So for storing the information that I'm going to be getting, I need something, and that is nothing but my variable. So a variable is like a container. So we all use containers, like we use boxes, we use water bottles. So what is the use of that container? The purpose of a container is to store things and keep. Same thing is nothing but my variable. So a variable is nothing but a container. It is going to hold the data and keep. So whatever data I am going to provide, it is just going to hold the data and keep until I make use of that data somewhere within my program. So now the next thing is, a variable is also what we call as an identifier. So identifier, what is an identifier? You remember we already discussed about this. So an identifier is nothing but a name. So a user defined name. Here who is the user? I'm the user. I'm the one who's writing the program. So the name of a variable is something which I have to give. So I have to remember some rules and regulations. So all the rules we saw for the identifiers, that is applicable over here also. So I have to remember when I'm going to give a name for my variable, I have to remember all the rules. And then I have to give a name which follows those rules. So I hope you guys all remember that. So if you want, we can quickly go through that. So what are the rules that we said? The name must always begin with an alphabet or an underscore symbol. So keywords cannot be used, special characters cannot be used in a name. So all these were some of the rules that we were following. So the same rules is applicable over here also. So have a look at this. These are some of the valid variable names. So I can give, okay, yes, value, yes, someone, yes. Remember, what did I say? Starting character must be an alphabet or an underscore. Subsequent characters, it can be anything. So that is not a problem. So then average underscore marks. So yes, this is also valid. X1, yes. Then email ID, yes. So the alphabets can be either an uppercase letter or a lowercase letter. It doesn't matter. Right. So all these are valid variable names. And same way here, these are some variable names which are invalid. So for example, I'm saying 1, 2, 3, ABC. It is not possible because starting character is not an alphabet or underscore. So this is invalid. Return. Return is one of the 32 keywords what we have in our C language. And I already told you, identifiers, keywords cannot be used as an identifier. So this is also invalid for us. So here, look at this one, average marks. There is a space in between. So spaces is not allowed because it is a special character. So that is also not valid. And here, I have a @ of symbol, which is again another special character. So other than underscore, I cannot make use of anything else as my variable name. So all these are some of the invalid. Right. Okay. So now let us look how to declare a variable or how to create a variable in my program. So what is the syntax I have to follow for that? So the syntax is something like this. So just have a look. Data type. So first thing is I have to mention the data type. Remember, we already discussed about the data type also in detail. So you can check that video out. So data type is the first one what you have to mention, followed by a space. Then you have to give the name of the variable. And of course, ending with a semicolon. Okay, so let us try this out. So here I'm just simply going to say int. Int is a valid data type. I am saying yeah. Now I'm going to execute this. See, this is not going to run, show any output or something because there is no print statement in it, but it will not generate any errors also. Why? Because it is a valid variable name. So no error is generated. At the same time, nothing is also getting printed for us. Okay, now look at this one. I am giving average space marks. Now let me run this. See what is the output I'm getting. Obviously, it is throwing me a compilation error. So it says compilation failed. Why? Because space. I told you, in between a variable name, we cannot make use of any special characters. Either we have to keep this together and then now we can run this. Yes, this is valid. Or what is the other option we can do? If we want to use it as a separate word, then you can make use of an underscore symbol. So we can keep an underscore here and then we can run this. Now also it is acceptable. So these are some of the rules. See, no error now. So this is how I will be creating my variable. So this is creating a single variable. So I can create like this of any data type, any valid data type. So I'm saying float. So float salary. And then I'm just saying char name. So name, I'm saying maximum of 50 characters. So the name is going to comprise maximum of 50 characters. So like this, I'm going to be creating the variables. So these are individual variables. I'm creating only one single variable at a time. Like this, I can also create multiple variables at the same time. So it is not that always you have to create the variables one by one. We can also create multiple variables at the same time. There is one very, very important point that we have to know whenever we are going to declare multiple variables. That is, all the variables that you are going to declare will belong to this one particular data type only. So it is not possible for us. Multiple variables means this V1 will belong to one data type, V2 will belong to another data type. No, it's not like that. So all the variables that you are going to declare here, okay, will be belonging to the same data type, whatever data type you are going to mention here. And each and every variable needs to be separated by a comma. Say for example, okay, so let us take this. I'm just going to say double. So D1, comma, D2, comma, D3, comma, D4. So here what is that I'm doing? I'm declaring 4 different variables. So D1, D2, D3, D4. All these are 4 different variables. Okay, so how to show that they are different is with the help of my comma. So comma here is like a separator. So it is to show the difference. Like this is the first variable, this is the second variable. Now all these 4 variables belong to the same data type, that is nothing but double. So this is also possible. So how we want, according to our program's requirement, we can create the variables in any of the method. So I want to create only a single variable. Okay, use this syntax. I want to create multiple variables of the same data type. No problem. We can make use of this particular syntax for that. Right. And the third variation. The third variation is I want to declare the variable as well as define some values for it. So here what we have done, I have created all these variables, but I have not initialized it with any values. So average mark. So what is the value that is going to be stored inside that variable? As of now, nothing. It is just going to hold some garbage value. So garbage value means what? Some random values. Okay, which is of no meaning at all. So meaningless values. So I don't want to create variables like that. I want to create a variables with some meaningful values. That is, I want to create a variable at the same time initialize it with some value also. So how to do that? What is the syntax for that? So for that, I can follow this pattern. So data type followed by the variable name. Then we are going to make use of the equal to. So equal to, as you know, it is an assignment operator. So it is used to assign the values. So whatever value we are going to mention on the right hand side will be assigned to the variable that is given on the left hand side. So this is how we are going to be doing that. So an example for that also, let us just say int age is equal to 10. So here what happens, the name of the variable is age and it is going to hold an integer value that is nothing but whole number. And what is the value it is going to hold? It is going to hold the value as 10. So now remember variable. So it is not a permanent value. The values can keep on changing also. So here at this starting, that is when I'm going to create the variable, I am giving the age as 10. Suppose, let us say, again, somewhere in between my program, I'm changing the value. I'm saying age is equal to 25. Yes, it is absolutely possible because it is not a fixed value. It's a varying values. So it's a variable. The values can keep on changing. So it is just a container. So whatever you're going to hold inside that container, the values can keep changing. Say for example, lunchbox. So lunchbox is a container. Is it like you can store only one item inside that? No, right? We take different items every day to our school or colleges. So like that only my variable is also of that. Okay, so here what is that? It is created of an integer type. So it can hold any whole number. Either it is a positive number, whether it is a negative number, whatever the value it is, I can keep on changing it. No problem. Say for example, again I'm saying age is equal to, so minus 50. Technically, it is not possible. Age cannot be a negative value in a real-time scenario. But just for an example, I'm mentioning it. So yes, it can hold. So the value of age is keep on changing in each and every line. So when the program is at line number 10, age variable is getting created with the value 10. So when the program comes to line number 12, the value stored in this particular variable is now changed. So whatever is the previous value, that will be overwritten. That will be changed to this newly assigned value, which is 25. Again, when it comes to line 14, once again, whatever was the previously stored value, previously overwritten value was 25. So now this value will be replaced or will be changed with minus 50. So this is how I will be creating a variable and also initializing it with some values. Right. So these are the different ways in which I can create my variables to make use of it within my program. Okay. So what is the important point you have to remember? Every variable that I create has some attributes. So what are they? Every variable will have a name. Okay, let us just say int a is equal to 25. This is my variable declaration and I'm initializing it with a value. Right. So here, what is the name of the variable? A. What is the value of the variable? 25. Now, what did I say a variable is? It is nothing but a name given to a memory location. So please remember, whenever I create a variable, okay, a memory space is getting allocated for it. Simple here. When you want to store some, you're creating a new Word document in your laptop or in your system. That Word document is going to occupy some memory space. Anything, you're creating an Excel sheet. That Excel sheet will occupy some memory space. This image, I'm showing you this image. Naturally, this image also will occupy some memory space. So that memory space, that memory location where the variable's value is going to get stored. So that address is actually allocated by my system. So every variable I create, that variable is just a name which will be pointing to the memory location. Inside that memory location only the value will be stored. Right. So what is that memory address? That is something which my computer decides. So you as a programmer, you cannot decide the memory address. As a programmer, what are the things we can do? Variable name is something which you will decide. Whether the variable name is going to be A, B, C, D, whatever it is, you are going to decide that. What is the value that needs to be stored inside that variable? Again, it is in the programmer's hand. He or she can decide that also, what variable needs to be stored inside that variable. But please remember, address. So the address that will be allocated for that particular variable, or that variable will be pointing to which address, which is something which you cannot predict. The memory address is always decided by your system. Okay, so but remember, each and every variable you create will be definitely pointing to a memory location. So here I'm assuming that variable A is going to be pointing to a memory location, say 7800. So this is the memory location which my A is going to point to. And inside this memory location, what is going to be stored? This value 25. This value 25 is going to get stored inside this memory. Okay, so now every variable that we create will also have a size. Size in the sense, what do you mean by that? How much of memory needs to be allocated? So I am storing, see, data is of different types, right? So I have a number, I have a floating point values, I have a string, I have a single character. So information can be of different types. So how much of memory is required to store that particular data? That is also decided. So every variable you create will have a specific memory size also. So the size is actually decided with the help of my data type. So the variable belongs to what data type? Based on that, the size is given. So here our variable is an integer data type. So since I'm assuming my system is a 64-bit machine, so integer is going to occupy 4 bytes. 4 bytes of memory will be allocated for this particular variable. Right, and of course the type, which is nothing but an int, or what we call as an integer. So these are the attributes of a variable. So every variable that you're going to create in your program will have this following attributes. So it will have a name, it is going to hold some value, it will be pointing to a memory address, and it will be having a size allocated to it. And of course, it belongs to a particular data type. So these are all the important points that you should be knowing with regards to our variables. Right. Okay. Moving on to the next one. So what are some key points? Okay. The first thing is just have a look at this code snippet. Okay. So here I'm creating how many variables? 2 variables. So I am saying int I is equal to 10, comma, j is equal to 25. So here I'm creating 2 variables and I'm assigning values for both the variables. So the order of the variable does not matter. In this declaration, the order of the variable does not matter. Whether I create I first or whether I create j first, it does not matter. So both the things are same. When I'm saying int I is equal to 10, comma, j is equal to 25, this is also valid. Okay, so same way when I'm saying j is equal to 25, comma, I is equal to 10. This is also okay. No problem. Why? Because both of these are independent variables. They are not interlinked or they are not interdependent on each other. So I is a separate variable, j is a separate variable. So it has no relationship between each other. So it is okay. So whichever manner, the order does not matter. Say for example, let me take this. Okay, and I'm going to paste it here and run this. Okay, I'm just going to run this. See, no error. If I change this order, okay, so here what I'm doing, first I'm creating j and then I'm creating I. Okay, I'm going to change this order. Run this again. See, now also there is no error. It is accepting. As I told you, both are independent variables. But look at this one. Look at this one. So here, what is that I'm saying? I am saying float. So the variable is of the data type float. So float A is equal to 1.5, comma, B is equal to A plus 3.1. So what is going to be the value of this variable B? Whatever is the value of A, that value plus 3.1. So what is necessary here? The A variable should already exist. So when I come to this B, A variable should already be present. Then only that value can be added with this, and then that new value will be assigned for my B variable. So here for this type of variable creations, that is where there is a dependency, the order in which you create a variable is very, very important. So now when I run this piece of code, okay, see, this is valid, it is accepted, but change this. Let us change this. First I'm saying B is equal to A plus 3.1, comma, A is equal to 1.5. Now run this. See what happens. It says A is not recognizable. Why? Because A has never been created. It is going to come one by one. So first it is seeing the data type. Yes, float. Then it is seeing the first variable what is being created. B. So I'm saying B is equal to A. So how will my compiler know what is A? Because we have not yet created A. A is here. So that is why I said the order of the variable generally does not matter if both are independent variables. But when you are going to create variables like this, that is based on the first variable's value, the second variable is going to get created. Then it is very much necessary that the order is important. We have to make sure first the variable is present, and then only we can move to the next one. Right. And there is one more important point what you should be knowing is you can create variables like this. That is, here what I have done, I am saying int A, B, C, D. So 4 variables, we already saw that it is possible for us to create multiple variables. So yes, now I want all these variables to have the same value. So instead of giving like this, instead of saying A is equal to 10, then next one, B is equal to 10. The next one, C is equal to 10. And then the last one, D is equal to 10. So instead of writing like this, 4 separate statements, I can do it in this manner. So I can say A equals to B equals to C equals to 10. So now what is going to happen? Remember, first thing, the value 10 is going to get assigned to this variable C. Then this value is going to get assigned to B, and then this value is going to get assigned to this variable A. So yes, this is valid, but remember, don't do like this. This is not possible. Why? Because first my compiler will start from here, int A. Okay, int A is equal to, what is the value of it? B. But what is B? I have not created, I have not come to B at all. So how can I assign that B value to A? So please remember, this type of variable declaration and assigning the value is a valid one. This is not possible. So if you're trying to do it, this is going to again generate a compilation error. So these are all the important things that you should be knowing with regards to our variables. Okay, so furthermore, we'll discuss as we go into the programs. Right. Thank you.